A one-dimensional steady flow hydraulic model called HECRAS is intended to help hydraulic engineers determine rivers and analyze channel flow. The model finding can be used in study on flood insurance and floodplain management. With the help of a hydraulic model, it is possible to quickly change any important parameters like meanings. Most of the drainage are connected to Sungai Johor which separate the flow of water around Johor. Some of the area were flooding that caused by overflowing due to heavy rainfall. As an example, the flooding was caused by the Johor River overflowing due to heavy rainfall on 2 November 2022 with the water spilling its banks. The city was affected too because of the low effectiveness of the drain in the heavy rain season, while in Segamat, the Segamat River overflow which is causing the flood to the areas. The engineers were given a task to analyze and modify the effectiveness of drain which be the one caused that city was flooding.
Hi, my name is Muhammad Syami bin Rosman and now I will explain for the methodology. Firstly, we need to create the river ridge based on the project instruction and the junction will be inserted starting from 0 meter to 1177.5 meter in geometric data section. Next, we need to create the cross-section of every challenge by using the cross-section data provided in the project instruction. So here is the outcome of cross-section. We insert the coordinate and the many values into the table, identify the left bank and the right bank, and across we create a cross-section. So this is the cross-section for challenge 0 meter. And this is the cross-section at challenge 150 meter. Next, this is the cross-section at challenge 300 meter. Challenge 600 meter. Challenge 800 meters. Challenge 900 meters. Challenge 1000 meter, challenge 1100 meter, and lastly, this is the last cross section at challenge 1177.5 meters. Next, this is for the steady flow data. Steady flow data will use this table keyword when doing the analysis. Firstly, the number of profile will be set and being named. The student needs to copy all the channels of the river and insert the discharge value based on the table previously. Next, the students needs to set the boundary condition. In this project, the student needs to set critical depth for all profile. After that, the student will do the steady flow data analysis for the subcritical flow regime. The student need to press compute button to finish the computation. So this is the result obtained after the analysis. There is no problem when key in the data. And for the last part, the student will get result data. The result data consists of profile plot, general profile plot, and lastly the profile output table. So the first one, here is the result for profile plot. Next is the result for general profile plot. And for the last one, this is the result for profile output table. So that's it from me. Thank you.
Hi, my name is Aidit Mustaqim. I will present the result and discussion of our HECRAS project. So, to build an accurate hydraulic model, the stream channel and the overbank region floodplain must be accurately modeled. So, to solve the problem of our project, the channel 0 to channel 1177.5 that showed the overbank region, we had the modification for all channels. So this is the check for the channel 0 before modification, and after we modification use the coordinate, the river just like that. Channel 150, channel 300 before modification, after modification, channel 600, the water is into the river, all of is under the line. Channel 800, channel 900, channel 1000, channel 1100, and lastly channel 1177.5, the before modification and after modification. So in HECRAS we learned that we can get the profile plot that of a crust can steady flow and unsteady flow computational results. It can show the water surface elevation, energy grade line elevation, critical depth elevation, and more. From the figure, we can see the elevation of Sungai Johor Alo channel 0 to channel 1177.5 that has been modified so the flow into each channel improves and does not become flooded again. So this is before that we can see the river is flooded, and this is after that Sungai Johor Alo A121 not flooded again. Last but not least, we can get the profile output table. So in this we can discuss that the difference of our before and after modification. From the figure given, we can monitor what is changed after we modified the channel. So here are the result of profile output table for before. So we can see what is state before we modify it, and this is after, so we can see the difference between that. I will continue to present the conclusion of our project HECRAS. In conclusion, through our original groundwater flow system in an effort to enhance the depiction of hydrological profile in drain channel, so we as an engineer, this was achieved by creating a straightforward, approximate analytical solution to the coupling problem which served as the mathematical foundation for the suggested method. So it is acknowledged that this study was limited to the extent of groundwater discharge to the surface water and not the other way around. Last but not least, the methodology should be extended to transit scenarios with caution because it was developed under steady-state conditions, especially to handle different time scaling and potential HECRAS instabilities. That's all from us. Thank you.